Hello guys, and welcome back to another episode where today I'm going to be showing you how to do some math. I know this is not like my usual content, but exams are popping up. Some people might be wondering, hey, how do I do some of this? I need a memory jog from this entire year. So this is basically an exam review video. So this is mostly to maybe teach you a new thing, but to jog your memory for the most part. So these are the four systems or parent functions. These are the parent functions. This is the constant. It's just represented by f of x equals 1. It's just a straight line with only on the y-axis. There's nothing really happening on the x-axis. The next one is linear. It's f of x equals x. It is the classic, this line. The next one is absolute value. Absolute value is f of x equals the absolute value of x. That's easy to remember, and it's a v. F of x equals x squared is the u shape. That's probably the line that you use the most. Next, after you guys have mastered the parent functions and memorized them, you should remember the translations and transformations. Now, this is the easy stuff. This is like moving right or left, up and down on the graph. Now, to move right, you have a negative, and to move left, you have a positive. But they have to be in the parentheses. See these? Parentheses. So this right here is saying that it needs to go 4 to the left. So if it was on the graph, parent function, it would be going 1, 2, 3, 4 over here. Now, if it was a negative, that would mean it would be going 4 to the right. 1, 2, 3, 4. Bam, right there. So if it's positive, it goes to the left. If it is a negative, it goes to the right. Next, we have going up and down. This is the easier one. This is without parentheses, and this one makes sense. If x is plus 1, we go here, this 1 up, there. If it was x minus 1, easy, it'd just be going 1 down. So if it's negative, it goes down, and if it's positive, it goes up. Next, we will be doing reflections. Reflections are easy. So if f of x equaled negative x, that's an easy one. The graph would look like the parent function. Let's do better. The parent function, but it would flip the x-axis to look like that. When the negative is outside parentheses, it is a x-axis reflection. So regular parent function like that, it would just flip it to go like that. If it was not in parentheses, it was just just like this. It was inside parentheses. That means it is a y-axis shift. So it would go from looking like this to looking also like that. That's crazy. That's crazy. Linear reflections all look the same. I'll give you guys a better example. Never mind, there is literally no better example, because with the U-shape, a reflection of the y-axis with the U-shape is, guess what? It's a U-shape. Parent function of absolute value, function of the y-axis. Wow. But it's most easily described if there's like a plus 2. Plus 2 means 2 to the It means 2 to the left. But let's just make this easy. Make it square. So it'd be right here. Now reflection would be there. Now you can actually notice it. Okay. After reflection, we go to vertical stretching and shrinking. Now, vertical stretching and shrinking is easy. It's f of x equals a, let's just go with higher than 1. 2x, like that. Now, let's make this squared. So here's the parent function, and we want to stretch it. So this 2 would make it look like this. It is a vertical stretch. What? No, it wouldn't. Wait, no, it wouldn't. Hold on. My bad, guys. I was thinking of the next problem. It would be looking like this. Let's just get that in. Okay. A vertical stretch is when it is inside the parent function, and a vertical shrink, which would be something like, let's just say 1/2. That would be outside, like this, being outside the parent function. Yeah, okay, sorry about that, getting confused, but yeah. It is a stretch if it is greater than 1 and inside the parent function, and it is a vertical shrink when it is outside and less than 1. Okay, now we go to horizontal stretching and shrinking. This will be f of x equals any number, let's say 2x. So vertical shrinking and stretching was on the outside of the parentheses. This one is on the inside. This should look like any number above 1 would be shrinking, and any number below 1 would be stretching. So if we make a graph, this is the parent function. A horizontal shrink would look like a higher than 1 number and look like this. Well, a lower than 1 number, like 1/2, would look like this. See? Okay, now that we got that out of the way, we can just go to the last part of the chapter. Last part of the chapter 1, is just slope, intercept, and point slope intercept form. No, point slope form and slope intercept form. Slope intercept form is a classic y equals mx plus b. Now, if you took anything in geometry and algebra 2, you should know how to use this. So I'm not going to get into that. And point slope form is y minus y1 equals mx minus x1 in parentheses. Now, usually, if you just memorize this, you can just take the numbers that they give you in like the problems and just pop them in there, and it'll be really easy. So this is about it for chapter 1. I think there is one more thing where it is 3 equations. So 3 equations just is like literally what it means. You have 3 equations. Let's just do this one. So you just take one equation, maybe just the top one, and you just combined the other two to this one. So like that, and like that. For instance, let's just go with this next one. Let's continue that. Now, if you notice, I took the first equation and multiplied it by -5. So the x plus y plus z equals 2. I just multiplied it by -5. So -5, -5, -5, plus, and -10. Then I combine that with the second equation, which is 5, 5, 5, and 3. So that leaves us with 0 equals -7. This is a no solution because you can't have 0 and a number. You need a x, y, or z value equaling a number. So this is no solution. And basically that's how you do it. You just, with any type of 3 equations, you just take any one of the equations, then combine the other 2. But if it's like this equation and you take the top equation, multiply it what you need to, then you take the bottom equation and you just combine them, and it gets you 0 and a random number. It's going to be no solution. And that is basically chapter 1 in a nutshell. So, now we finished basically all of chapter 1. Let's go on to some review. I'll be doing 1 through 9 on page 38 and 39, just to give you a basic idea of how it's happening. So number 1 is to just graph the parent function and this new function that is given to me. The first function is a linear one. So just graph the parent function, and it is going up 3. Wow, that's easy. So, next one is having an absolute value. As absolute value, so that's parent function minus 1. Go down 1. There we go. Should look like that. Next problem is a stretch or shrink of horizontal. It is a horizontal stretch or shrink. It is below 1, so it is going to be a horizontal stretch. So let's just write this down. It is Q, so there's the original parent function. Now it is a horizontal stretch of half, so just something like that. Easy. Next problem is x equals 4. Parent function 1, 2, 3, 4. There we go. That's the answer to number 4. Number 5 is an absolute value. It is negative on the x-axis. So it is a reflection of the x-axis, and it is minus 3. Okay, there we go. There's parent function. It is reflected, and negative 3. That's 1, 2, 3. Something like that. Just parent function down 3, then flip it. Okay. Number 6 is going to be a x-axis flip with a vertical, looks to be stretch, and it's going to go to the left 3. 1, 2, 3. Oh, I should probably do the, it's a cubic. No, it's going to be a quadratic one. Now, it's going to the left 3. It is going to be flipped on the x-axis, and it's going through a vertical stretch. So, it should be a lot skinnier than the parent function. Okay, now, number 7. It is giving me some functions, and I need to add the stuff that they're saying I need to add. So, I have, let's just see that. I have an absolute value with a reflection of the x-axis and translation 4 units to the left. 1, 2, 3, 4. There we go. That's all I do for that one. That was number 7. Now, number 8. I have another absolute value with a vertical shrink by a factor of half. Vertical shrink means it gets wider than the parent function, and translations 2 units up. So vertical shrink and 2 units up. So that's 1, 2. It's going to be wider like that. Now the last one is finally different. It is not that one. It is this one. It's a linear problem where it needs to go 3 units down and a reflection on the y-axis. 1, 2, 3, and there we go. That's basically what I summed up in this entire thing. That was most of the review. Thank you guys for watching. I'll see you guys in Chapter 2.